areas are enzymology, bioenergy, protein chemistry, and ma'am has a very excellent H index and 18 index in the literature. Thank you, ma'am, for accepting our invitation for giving this lecture to our participants, online participants in Agribusiness and Incubation Center, December 2020 season. Thank you, ma'am. Please, I'm giving it over to you, ma'am. Please continue the lecture with the participants.
Thank you, Professor Machavaram. Thank you for your excellent introduction. Let me share my can't share your screen. Why? Why my screen is
enter screen?
Enter screen.
Okay. Share.
Here it is not giving permission, so dear participant, it is I'm really feeling bad. Let me go down. My appeal is not allowing me to. Just wait for some time. I will.
Presentation করবে তো করতে পারছি না কি করবে ওটা খারাপ আছে নাকি এটা হ্যাঁ না ও হয়তো জানা নেই কিভাবে করতে হয় কি এই ম্যাডাম
I request all the participants please mute your mic during the session, and yeah, you can interact with the ma'am at the end of the session or whenever ma'am calls for discussion. Yeah, just in 2 minutes we will be continuing because of the some technical problem in the computer. Ma'am will join in 2 minutes. Please be patient. Yeah, good evening all. Good evening, Subhajyoti. For the previous lectures, you can also see in the YouTube live, and feedback form is also given in our Facebook link. You can go through that if you have missed the previous classes. Yeah, in this session we will be giving 10 lectures. Total 10 days. The last day is on Thursday. By Thursday it will be ending. Mr. Ayush. Yes, yes. For online participation in Google Meet, we will be giving as a stage wise. For others, through YouTube Live, we will be giving as a session. The others can see through YouTube. And here we are permitting 100 participants at a time. No problem, Ayush. You can attend the previous day lecture. The details are there wherever you are registered earlier. There also you can see the details. Otherwise, the details are also there in our Facebook page. I'm sharing the link here, the Facebook link. The details are over here. We can listen the previous lectures if you have missed. Yes, ma'am. Good evening.
But I cannot hear you. Can you hear me?
Yes, ma'am. We can hear you.
But I cannot hear you. Am I audible?
Yes, ma'am.
Click on. Click on.
No.
Then what do you ask me? Cost. I understand that you are experiencing an issue with PC audio. and please come for the common solution.
কি করবো? ইয়েস
দেখো অন করাই তো আছে।
ইয়েস, ওয়ান মোমেন্ট। নো স্পিকার।
মাইক্রোফোন তো ঠিক আছে, স্পিকারটা অন হচ্ছে না।
সুব্রতকে ডাক, সুব্রতকে ডাক। আচ্ছা, কি am I audible?
Yes, ma'am. You are audible.
Am I audible?
Yes, ma'am.
Can you hear me? Yes.
Yes, ma'am. You can see.
Yes, madam. So, but I cannot hear anything. I cannot hear.
Again?
Can I go ahead with the
Yes, ma'am.
presentation?
Yes, ma'am.
Off ଅଛି ଆଜ୍ଞା।
ଅଛି ତ ବେଶୀ ଅଛି 100 ଆଉ
କେତେ ହେବ? ରିକନେକ୍ଟ ବୋଲି ଲେଖିଲା।
চারটে থেকে শুরু হয়ে গেছে আমার প্রেজেন্টেশন, এখন পর্যন্ত আমি কানেকশনই দিতে পারলাম না।
হ্যাঁ হ্যাঁ এসছে।
এই তো এখন এসছে, এই তো জয়েন নাও। আচ্ছা, এবার শেয়ারিং এ, এবার আমি তো শেয়ার করতে পারছি না।
এখনো শেয়ার হচ্ছে না?
কোথায় শেয়ার করতে পারছি না? এই যে এখানে স্টপ শেয়ারিং, এই যে এতগুলোতে এসছে। এটা কি আসছে? কি আসছে এটা?
কি জানি এতগুলো এসে গেছে।
কার্টুন অনেকগুলো খুলে গেছে।
বড় করুন এটা।
অনেক বড় খুলে গেছে।
আমি তো সেটাই বলছি।
স্টপ শেয়ারিং করবেন স্যার।
এবার
গুগল মিটের লিংকটা।
যায় না। আচ্ছা, হ্যাঁ, ঠিক আছে। প্রেজেন্ট উইন্ডো, শেয়ার, কোথায় প্রেজেন্ট?
It is visible. You can continue. It is there.
But
I cannot see that.
huh?
We cannot see. We can see.
Is it?
Yes. Yes, ma'am. We can see.
Shall I?
We can.
Shall I?
Yes, we can. I can hear it. There I can show this.
Okay. So, but whether I have stopped the live audio.
No, no. It is audio is there.
Huh?
Yes.
Hi. Audio is there?
You have closed again. You want to share it?
Huh?
Please. I am presenting. Yeah, you can start now. Audio is
Okay.
also there.
Okay.
You continue.
Okay. So good afternoon, everybody. So today my talk is on biogasification from lignocellulosic or any waste material. So if we see that any organic matter which is subjected to decomposition, uh, it is happening in two ways. One is under in presence of oxygen, another is in oxygen stressed condition. So the most organic matters
Madam, still we are not seeing the presentation.
is there? Ritik Shah.
Microphone is working. Speakers, which is this common speakers?
Camera. Is off here.
Okay.
Technical problem. Yes, and now it is shared. Who is full screen? Yes. Yes. I think now it is properly done. So biogas is a result of such decay, which I have already mentioned till now, and it is a source of energy which is used as fuel. And there are certain technology which are generally used by the population for the production of total methane contained in the biogas. So when we are just talking about biogas, it typically refers to a mixture of different gases which are getting produced during anaerobic fermentation of the organic waste material in absence of oxygen. That means when I'm talking anaerobic fermentation means not in presence of trace amount of oxygen. Now the question may comes that when I'm talking about moisture, so moisture also, that water molecules, it contains some oxygen within it. So what will happen to that particular oxygen percentage which is coming along with the water molecules? So in that condition, in this, while analyzing this situation, we have to have some idea about what is the mechanism of biogas production. So when we are just talking about biogas, it is produced from raw organic material, raw biomasses. That is agricultural waste, it may be the waste manure, municipality waste material, the leftover plant litters, sewage, green waste, or any type of organic waste that can be subjected to the gasification process where no oxygen will be there. Nowadays, if we see the methane generation, you will be finding that people are going for CNG, compressed gas. So when we are just going for this, then how we can increase the fuel efficiency? Now, if we see the gas production and mixture of gas, then we can find that biogas is a composition of a number of gases that majorly contain methane as a fuel gas, but along with that, carbon dioxide is also getting produced. But carbon dioxide is not at all helping, or it is a burning gas. So in its presence, the fuel efficiency is getting compromised. So what is the recent approach is that to remove or scrub carbon dioxide from the mixture of methane and carbon dioxide, which is present as a major composition of biogasification. So when this biogas is getting produced, what we are doing, we are saying that 60 to 65% of methane is there in that particular gas, and 30 to 35% carbon dioxide is present in that composition. And what is the leftover? The leftover gas may be hydrogen sulfide or carbon monoxide or trace amount of hydrogen which is also getting produced along with this gasification process. That means we can tell from this particular composition that biogas is not a single gas, but it is a mixture of gas which is getting produced by the fermentation, anaerobic fermentation of the organic waste material, and that is producing 60 to 65% methane, which is our targeted gas. Now, if we consider, if we take care of this 60 to 65% of methane, then what will happen to the rest carbon dioxide, which is the major constituent of this gas? It is getting released to the environment. As a result, what is happening, the carbon footprint which is there is gradually getting increased. And under these circumstances, we cannot claim that it is the carbon neutral or carbon positive process. So what is to be done? We have to be very, very careful. We have to take care of the carbon release to the environment, because we are taking care of the waste material. And for utilizing the waste, we should not once again go back to the environment where the carbon footprint is getting released or accumulated as a result of the outcome of that particular process. So the process what we have to select is either carbon neutral or carbon negative process. So how we can do this process? If we can utilize, instead of releasing this carbon dioxide to the atmosphere, if we can appropriately utilize this carbon dioxide for some other product or byproduct generation, then only we can claim that the carbon release is almost zero or negligible. Then only that process will be the eco-friendly, and we can go for carbon neutral or carbon negative process development. So this is the present thrust. So if we see the biogasification process, then you will be finding that this is an age-old process. So many people have done this biogasification from many years. But what is that? Till today, people are trying for biogasification. Where is the innovation? Where is the new input? Here is the new input, where we are just totally changing the process of gas production, and we are trying to utilize the byproduct to make it the soil-to-soil technology. Now, if we are just seeing the waste material, that waste may be from any sources. It may be from animal sources, it may be from the vegetable or biomass, waste biomass, and when we are subjecting this particular waste material, and those waste are majorly organic in nature, and we subject it under anaerobic fermentation process, then we are going for the gasification process. The methane, which is a fuel gas, is very easily getting converted to electricity through a micro turbine, and the carbon dioxide, water, and the other hydrogen, carbon monoxide, hydrogen sulfide, and other gases, hydrogen, which are getting produced, that are getting converted to fuel gas, and the carbon dioxide and water is getting utilized to the environment which is being taken up by the plant for its growth and metabolism through photosynthetic process, and once again as a result oxygen is getting released to the atmosphere. But this is the traditional one. The release of carbon dioxide to the atmosphere is gradually getting increased in such a manner that accumulation of carbon dioxide in the atmosphere is gradually getting increased. As a result, the release of carbon dioxide and utilization of carbon dioxide is not getting balanced. As a result, carbon dioxide accumulation is increasing, and that has resulted into the greenhouse gas accumulation and environmental changes. So here in this particular picture, not only this energy crop and manure, what we have talked about, the industrial waste and different sources of waste that is also considered nowadays for anaerobic digestion, and as a result we are going for electricity generation. Directly we are just using this methane as a fuel gas. We are going for the residual solid biomass for biofertilizer production, and the leachate which are there is used as a foliar spray, and also we are going for the composting. So as I have mentioned that if we see the history of biogas, then we can find that it is in 1630 this gas was first evolved, and then the continuous work on this gasification process has started, and till now we are going for the biogasification. If we see the biogas production process, then the mechanism of gas production is very, very interesting. Although I have stressed upon the anaerobic fermentation of the organic waste material, but in reality, it is not at all like that. And if we see the science behind this biogasification process, then we can find that there are different groups of microorganisms who are playing a significant role in this conversion process that is resulted in this gas formation. Now, when I'm talking about this organic waste, I talk about the anaerobic digestion, and this digested slurry is coming as the biomanure, and we are further subjecting this slurry to further enriched into N, P and K, where we are going for the enhanced or enriched biomethanation process. If we see the potential sources of this gas production, we can find that although I'm telling that lignocellulosics or green or waste material, but as such the science is not that easy. We are classifying this particular lignocellulosics potential biomass into different categories, and when we are just talking about the huge quantity of gasification process, we have to have some idea about the availability of these lignocellulosic wastes. How much is the production and the productivity in our surroundings, so that we can consider this waste for the biogas production. When we are going for this particular waste material, India being the agricultural based country, we are producing huge quantity of paddy. As a result, rice straw, rice husk. We are also producing wheat in large quantity. So wheat straw, jawar straw, bajra straw, maize stalk and maize cobs. And there are very many such pulses, lentils, rapeseed, and some oilseed crops, cotton, cotton seed waste, jute, sugarcane bagasse, sugarcane leaf. So this type of raw materials are available in millions and millions ton. So if I take sugarcane as one of the example, sugar is getting extracted. Sugar is extracted and sugar industry is throwing the bagasse, and instead of throwing the bagasse, they are using it as boiler fuel. So this boiler is getting burnt, but the leaf, the greenery leaf, it is considered as the fuel, as the waste. So what we are doing, we are taking these leaves, instead of going directly for biomethanation process, what we the scientists we do, we are taking this lignocellulosics and we go for the biochemical composition analysis, and then we are going for its proper characterization, and then we decide whether we'll be going for directly biogasification or we will be going for some product development and then the carbon balancing, and then with that particular leftover we should go for biogasification process. Here in India, if we see the energy potential with the surplus residues which are there, this is the different states which have been mentioned here. You just see that different crop products are mentioned here, and you can find that the state who are very, very potential to be used as the waste production, agro-based waste production, and potential state for production of biogas or biofuel from such lignocellulosics. So when we are going for the classification of such biomass, we are just dividing the entire lignocellulosics into two parts. One is the grazing lignocellulosics, another is the non-grazing lignocellulosics. So grazing lignocellulosics has got some application which can be used directly as a fodder, whereas the non-grazing lignocellulosics, so when we are talking about what we are thinking that yes, these particular lignocellulosics are suffering from some problems for which it is not directly consumed by the animals as a feed or fodder. As a result, what is happening? These particular raw materials are considered to be the waste. And what people are doing, farmers, they are doing, either they are burning this type of raw material or it is getting buried under the soil. So at IIT Kharagpur, when we are going for this selection of this type of raw material, what we thought of that instead of using these waste material directly for biogasification, why don't we go for some other valorization of the product? And that may be the thrust of ours. And that has been the leftover, because solid residues are leftover when liquid is getting produced, and that solid residue is further subjected to biomethane generation. And when we characterize the lignocellulosic material, the agro residues, we found that it is majorly composed of cellulose, hemicellulose, and lignin. So cellulose and hemicelluloses are the carbohydrate moieties which help in biomethane generation, but lignin is one of such a robust molecule which cannot be digested so easily, and it remains as such, and it is unutilized and left over for the leftover product. So that is the reason it is essential to know that what are the different constraints the microorganisms or the living creature they are facing at the time of digestion, or in other words, we are calling it fermentation. So when we are just going for the fermentation process, we found that the major constituent of these lignocellulosics are varying from different sources of biomass. So it varies from biomass to biomass. If we go for the different product formation, then we can find that EMP pathway is very common. This is the hardcore science behind the biogasification process. Now, when we start for handling of lignocellulosics, what we have seen that the glucose moieties, say for example, cellulose is the complex structure of unit molecules of glucose which is getting linked with each other with beta 1,4 glycosidic linkages. So similarly for starchy material, the linkages are alpha 1,4 or alpha 1,6 linkages for the starchy material. So when these glucose are getting released, this glucose is taken up by some group of microorganisms, and these microorganisms convert this glucose and it is getting converted to some intermediate, and these intermediates are highly delicate and unstable product and immediately getting converted to one step, another step, another step, and that way 11 such steps are getting completed when we are getting the pyruvate. And when pyruvate is getting produced, we call that the end product of Embden-Meyerhof pathway, or in brief we call it as EMP pathway for pyruvate generation. This pyruvate under anaerobic condition. Now when this conversion, see the beauty of this anaerobic digestion is that when this glucose is available here during these phases of this conversion, there may be some trace amount of oxygen which may be present, but when it comes to this particular condition, under anaerobic condition only, this pyruvate is getting converted to acetic acid. Now this sugar is, so if I further go ahead with the system, then what I can tell that this sugar to pyruvate, so sugar, that glucose is a sugar, this sugar is getting converted to pyruvic acid. This pyruvic acid under anaerobic or stress condition may get converted to lactic acid. It may get converted to acetolactic acid, and this way the pyruvate can further subject it to formic acid and acetyl-CoA, and that way under aerobic or partially anaerobic condition in the living system, we can get propionate, isopropanol, butyrate, butanol, acetone, ethanol, and so many other 2,3-butanediol and so many intermediate products which are getting produced by following the standard pathway. Now you may question me that, yes, madam, we are interested for methane generation, but here we don't see any methane. So what you are teaching? So this is all blah blah. So we are not interested about this. But what I want to tell here that we are handling waste, and here we are not going for any sterilization process. Here, number of microorganisms are participating in this bioconversion process. So as an entrepreneur, what is your thrust? What you should see that when and under what condition which product is getting generated, and that may be my thrust of telling you the pathway, although I know most of you are not at all interested to go for all this complexity. So here, if we see that means what I have told you in the earlier slide, in this slide, that you see there are different products. None of these products are methane, but they are the intermediates, or they may get produced during anaerobic fermentation or inside the digester when someone is interested to go for the anaerobic or waste treatment method. So when we are going for the animal waste characterization, we find that depending upon the nature of the waste material, either some amount of proteins are available, some amount of lipids are available, some amount of cellulose, hemicellulose, and starchy materials are there. That means if we further analyze this, we can tell that these are some of the carbohydrate moieties which are there, and some lipid and proteins are also there, along with some amount of minerals which are also present in these waste residues. So we can get either C5 or C6 sugar from these carbohydrate moieties. This cellulose, under enzymatic method, that means under the presence of enzyme cellulase, is getting converted to C5 or C6 sugar. Hemicellulases, here they majorly release C5 sugar because hemicellulose is a mixture of C5 and C6. Cellulose is only C6 sugar. Starch is also made up of glucose, C6. So from here, the major constituent is glucose. So the enzymes which are released by a number of microorganisms, bacteria, or such fungi, they are majorly hydrolytic enzymes, and in presence of water, they act on the cellulose, hemicellulose, and starchy material and convert that to glucose. These glucose moieties are being utilized, and we have already seen that this glucose is getting converted to pyruvate. This pyruvate is further getting converted to formic acid, acetyl-CoA, acetaldehyde, lactic acid, and oxaloacetic acid. So in my earlier slide, you have seen that formic acid is further converted to carbon dioxide and water, and carbon dioxide in presence of some other metabolites, it is getting converted to acetyl-CoA, and this acetyl-CoA is phosphorylated and it becomes acetic acid, and when this acetic acid is getting produced, they immediately get converted to methane and carbon dioxide. Similarly, this protein, it is the constituent of amino acid. Say for example, 2 amino acids, I'm just taking glycine and alanine. This glycine is undergoing reduction reaction. Alanine is undergoing oxidation reduction, and they are ending up with different types of organic acid, and ultimately it is producing acetic acid. Similarly, the lipid which are there is the composition of either propionic acid, butyric acid, valeric acid, caproic acid, and other small molecule of other acids that are further getting converted to acetic acid and methane. So as a result, when the anaerobic digestion is getting completed with the intermediate molecules which I showed you in my previous slide is getting converted or ending up with methane and carbon dioxide. This ethanol under some stress condition is also getting converted to methane and carbon dioxide. So these are some of the intermediates. So here, if we see the microbiological aspects of the biogasification process, then what we can find is that the carbohydrate, fat, or protein undergo hydrolytic reaction. So what is a hydrolytic reaction? When we are just going for the breaking down of the macromolecule, because protein is a macromolecule, fats are macromolecule, carbohydrates are macromolecule. So carbohydrates like cellulose, starchy materials are macromolecules. These macromolecules are not acceptable by the micro creature, that is the microorganisms. So it undergoes some breakdown in presence of water. That means hydro means water, lysis means breakdown. So in presence of water, this breaking down process is taking place. As a result, we get amino acid, fatty acid, and some sugar moieties. And from there, we are getting different intermediate, and that is resulting to the ultimate product, that is methane and carbon dioxide. Up to these two steps, hydrolysis, acetogenesis, and acetogenesis, these three steps, when it is taking place in the reactor, we are getting that these organisms are such that they almost consume the oxygen present in, if any, in that environment, and they are trying to make that environment oxygen free so that the methanogens, which are actually the organism who are producing the methane, is actually active. And in this condition, when this acetogenesis is getting over, that means acid formation has already been started, and acid formation is breaking the pH down, and this pH is one of the very, very important parameter for methane generation. If it is extreme acidic, the pH falls beyond 5 or 3.5 to 4, and below that, all the microorganisms who are participating in these activities will die. As a result, what will happen? No acid genesis will be there, and no methane will be getting activated. So there should be a proper balancing of these two groups of organisms which are, so that means if 1 mole of acid is getting produced, immediately that 1 mole will be getting consumed or utilized by another group of microorganism if it is present in proportionate manner. Some of the examples which I would like to give you is that the first group, second group, and third group, if we are making the groups of this methane generation process, then we can find that Actinomyces, Acetobacter, Clostridium, Cellulomonas, and Klebsiella, and so many. There are more than 225 such reportings are there, more than 25 to 230. So these groups of genera are there where this group of microorganisms are actively participating in the hydrolysis and acetogenesis process. And there are certain group of methane who are majorly active in this particular, when this acid formation takes place, the reactor is almost oxygen free, and that condition only this methanobacteria formicum, methanobacteria bryanti, methanococcus volti. So these are some of the organisms. They feel very, very active that time, and they convert that acid to methane. Now, if I tell you that methane formation is done, why we are going for methane generation? So if I tell you that I have produced 1 cubic meter of methane, how 1 cubic meter of methane can be utilized? So how much is its heating efficiency or fuel value of that particular methane? So if we compare the fuel efficiency of methane, then we can find that the 1 cubic meter of methane or biogas, say for example 60% methane and 35 to 40% carbon dioxide is there. That constituent, that biogas is equivalent to 0.46 kgs of LPG, 0.6 liter of diesel, 0.55 liter of fuel oil, 1.2 kilowatt hour of electricity, and 1.5 kgs equivalent of firewood. That means if we burn 0.46 kgs of LPG, we are getting the energy equivalent to burning 1 cubic meter of gas. And that may be the reason why people are, till now, they are very much interested to go for such product generation and its continuous improvement. So now if we are talking about that, what one will be doing with 1 cubic meter of gas, I think many of you are rural based and you must have seen that electrification is there for running the HP engine and for cooking purposes directly, that gas which are there. So for cooking purposes, if that gas can be utilized, then what I can tell that 60 to 100 watt lamp can be lightened for 6 hours. A family can cook 3 persons meal a day, and 1 hour horsepower motor can be run for 2 hours if you have 1 cubic meter of gas. So these are some of these applications which has compelled us to go for the substitute, that what should be the alternative method or alternative substrate that can be added to this particular composition biogas digester, so that the amount of methane can be improved. See, I can tell you, methane, I'm talking about methane production. This methane can be improved by two ways. One pathway is that you go for increased methane percentage in the biogas. Say for example, you are getting 60% methane. If you are getting 65%, if you are getting 70% methane, then what will happen? Your percentage methane in a certain cubic meter, say for example 1 cubic meter gas, is getting improved. That means it is increased. Another way that you are not going for percentage improvement, but total volume of gas is getting increased. That is also another way of improvement of gasification process. The scientists like us, we are trying to increase this methane in both the ways, either by increasing the percentage of methane in the gas. Another, that if we can increase the total volume, say for example, earlier I used to get 160 liter of total gas, and now I'm getting 223 liter of total gas. That means my total volume of gas has improved. That means that much, it may not be 70%, it may be 60% earlier percentage, but total volume is increased, means total methane production has increased. So these are the different way of looking at your problem, that in which way, which option you will be selecting for your gasification process. Now, if this is so, then in that case, what we can see, the substitute of cattle dung. So see, if we see the cows and buffaloes, and if we see, if we can find that here the gasification is not that very high, 0.02 to 0.04 cubic meter. Pig is little increased, 0.04 to 0.059, say for example, 0.06 cubic meter. Poultry chicken, 0.6 to 0.11 or 12. And the most interesting part is the human waste, that is 0.02 to 0.28. So our human waste can also be subjected, can also be utilized for gasification process. And that way we are trying to punch these waste along with the agro residues for the total gasification process. Now, when we are going for this particular gas production, this biogas can be produced, I have already mentioned here, and biofertilizer can also be getting produced within this. So when we are just talking about this, we are talking about this methane, carbon dioxide, nitrogen, hydrogen sulfide, and oxygen. So in biogas, no trace of oxygen is present. So generally, we are getting very low concentration of hydrogen, because hydrogen is a little bit dangerous fuel, very lighter in nature, and that may be the reason it is sometimes that explosion, if the tendency of explosion is getting increased, if the percentage of hydrogen is getting increased in biogasification process. So although I have told that 60 to 65%, but one can go up to 75% of methane in biogas production, biogas composition. There are different ways of producing this biogas from the waste material. So when we are just going for this waste material, and when we are talking about the waste conversion process, then what we can tell is that there are some signs or engineering aspects which are further making us very interesting to go ahead with this biogasification process. So when we are just talking about this biogasification and its production, we generally talk about the two types of gas production process. One process is called fixed dome process, another is the floating dome process. Now, when we are talking about the composition of biogas, so here in this particular methane production process, I have told you that there are certain methanogens which are playing a significant role. So, if we see the methane producers or methane producing bacteria, then what we can find is that in methane production process, the methane producing bacteria, they are very primitive group of bacteria, and it is otherwise known as archaebacteria. These archaebacteria are very primitive, and the other bacteria which have participated in the hydrolytic and acetogenesis and acidogenesis process, they are the eubacteria, that is the developed form of bacteria. That means first the developed eubacteria are participating in this process, followed by archaebacteria, which are converting the byproducts of eubacteria to methane. We are just going for this. Has got some distinction from the eubacteria because it is otherwise known as that these bacteria are the extremophile. This group include lithoautotrophs and heteroautotropic anaerobes. These are the group of microorganisms which are absolutely anaerobic in nature. It is well known and established fact that this group of bacteria have many properties which can distinctly separate them from the eubacteria. If we see the archaebacteria, then we can find that in general, we are just staining the bacteria either gram-positive or gram-negative, but archaebacteria can either stain gram-positive or it stain gram-negative, and it may have either spherical, rod-shaped, spiral, irregular, plate-shaped, and sometimes it is pleomorphic structure, and that is getting varied from organism to organism, although the methanogens, they are the extremophile group of bacteria. They are used and found as a single entity in aggregates. Sometimes these bacteria are also found in a filamentous form. In general, the diameter is getting varied from 10 to 15 micrometer, but some filamentous can go up to 200 micrometer. So that is the reason archaebacteria are found mostly in the extreme or terrestrial habitats. The component which are there on the cell wall is distinct from that of the cell wall of eubacteria. And that is the reason you cannot go for the cell that gram-positive staining or gram-negative staining. And that may be the reason many a time people are getting confused that what type of bacteria it is. If we see the archaebacterial cell wall, then what we can observe is that it is, this cell wall is lipid transcription and translational operation, that apparatus which are there, prosthetic group and coenzyme, which are commonly present in eubacteria, are distinct from that of the archaebacteria. And there are several other distinctions of these eubacteria and archaebacteria. But the most interesting part is that oxygen tolerance. Many a time, methanogens are found to be very, very oxygen sensitive. 0.01 gram per liter of oxygen is toxic to these particular methanogens, and that is the reason why we have to be very, very careful while going for the methane generation. Many a time you have seen that methane production is very good, very good, very good. Then there is a fall in methane percentage, and in one fine morning you will be finding that total gas production is stopped. I don't know any one of you have this type of experience or not. So it is the methane which is getting produced by this group of bacteria, and that may be the reason we have to be very, very careful while handling or while designing the gasification and reactor design, that what type of reactor, why that type of reactor, and how that type of reactor will be helping someone for enhanced gas production. So these are some of the parameters which are there. And if we see the gas and different factors which can enhance the gas production, under which condition gas production is getting stopped, as an entrepreneur, what steps one should have to immediately restart the gas production are the major challenge of this particular profession. And if you know the science behind the biogasification process, then only it will be possible for you to address, to identify, and to rectify the wrong doings which has happened with your reactor system. I don't know, I'm not getting any feedback from any one of you, so I don't know that whether you are understanding or not, but it is a one-way process, so I'm just teaching and I'm just talking about this. So, if we are going for the production of gas, what I have already told is that either it is a fixed dome model or it is a floating dome model. So in a fixed dome model, there is a mixing tank. So biogas, which is getting produced, which is getting constructed, it is constructed with brick and cement, and the entire process is getting divided into 5 different sections. So one is the mixing tank, which is present on the ground level. One is the inlet tank. This is the inlet tank. And third one is the digester, where digestion is taking place. And another is the outlet tank, where after digestion, the digested slurry is going out of the system, and another is the overflow tank. So once it is the capacity of your particular plant is suppose 100 cubic meter, and you have added the liquid which is more than 100, then what will happen? From the outlet, your undigested material along with semi-digested or totally digested material will be going out. What is happening, when we are just feeding here in this particular tank, the initial feed is getting accumulated. So bacteria which are there along with this raw material, they are now active and they start converting this to the product. As soon as digestion is taking place, this particular material which are getting digested becomes lighter, lighter and lighter. As a result, what is happening, the lighter things it starts floating and it is coming from this segment to the other segment. And from here, it starts going out of the digester. But if in case it is the capacity, say for example, you have to give 50 kgs per day and every day you are giving 70 kgs. So 20 kg extra is there. So this 20 kg is accumulated, and one day will be there when it cross, and then it will undigested, semi-digested and totally digested things will be coming out and it will be going out of the system. So these are some of the issues which are to be taken care of. Here, in this case, the gas, as I have already mentioned, that either it is a fixed dome plant or a floating dome plant. So in the fixed dome plant, this plant is fixed, and the floating means another this gas holder is getting vibrated. It is getting increased or decreased depending upon the quantity of gas which are getting produced in this. The various form of biomass that can be mixed in equal quantity of water, and it is getting, its size may be getting reduced as much as possible, as this is forming a slurry. This slurry is fed into the digester through the inlet chamber. When the digester is partially filled with the slurry, or introduction of slurry is stopped and the plant is left unused for about 2 months or so, then only some digestion will be taking place. So here, many associated parameters are playing a significant role in this gasification process. During these 2 months of time, anaerobic bacteria which are present in the slurry, they become active and they start fermentation and they start decomposing the biomass. And as a result, anaerobic fermentation results into biogas formation, and it starts getting collected from the dome of the digester. So as more and more biogas starts collecting, the pressure exerted by the gas that is forcing the unspent slurry into the outlet chamber. From the outlet chamber, this spent slurry overflows with the overflow tank, and the spent slurry is manually getting removed from the overflow tank, and that is getting used as a manure for the plant. The gas which is getting accumulated is now getting connected to a system of pipelines, and that is opened with the supply of biogas. To obtain a continuous supply of biogas, the functioning of the plant can be fed continuously with the prepared slurry. In general, per day, we are feeding and it is not a continuous one. Per day, one time we are just opening and we are just adding the feed to the tank. But many a time, what is there in a big industry, there is a continuous flow of milk, the substrate, and continuously after digestion, the slurry is continuously going out of the system, and residence time here is, or hydraulic residence time here is playing a significant role. That is to be determined that how long you want to keep, or what is the efficiency of your process, so that the raw material will not be getting out of the digester in between, that half cooked manner. So it should be fully getting digested. So here, when we are just going for the biogas guidelines, so what data we have? If we are selecting a place where the temperature of that place is lying between 20 to 35 degrees centigrade, or it may go up to 40 to 45 degree also it can go. That is the ideal place for biomethanation process. The retention time also getting varied from 35 degrees centigrade to 35 days to 30 days, 25 to 30 days to it may go up to 100 days. Biogas which is getting produced is to be evaluated, and you have to find out that how much is the total volume of gas that can be produced from here. So once we are just going for this type of gasification process, we are then determining that how much is the gas and in which purpose we want to use that gas. Now, as I have mentioned here, that 20 degree to 35 or 45 degrees centigrade we can go. So if we are in that lower temperature range, our minimum temperature can vary from 4 to 10 degrees centigrade, and maximum can vary from 25 to 30 degrees centigrade. And under these particular situation, the duration of fermentation is varying. It is from 60 days to 100 days. So this is the condition where the fermentation time is getting exceeded. So these are the cold environment where the rate of digestion is to be taken care of. Now, if the temperature is a little improved, say for example 10 to 20 degrees centigrade, under this condition also some of the microorganisms are or can function, and it can go up to 45 degrees centigrade, and we call it as mesophilic group. First group is the psychrophilic or cold loving temperature bacteria, and some are moderate temperature loving bacteria, and some group of bacteria are thermophiles, that is high temperature tolerating bacteria. Say for example, in extreme summer, you will not be getting any problem in gasification process. Rather, in rainy season, many of you may get a huge quantity of this gas. So it has been seen that many a time, many of the beneficiaries, they think that if they put water, then only they will be compromising with the gas, and minimum, whatever is the requirement, that requirement is also not getting fulfilled with the miserly added water to that particular solution. So as a result, the total gas production is also getting hampered. So it has been seen that if the solid percentage is 8 part of solid in 100 milliliter of water, to 12 part of solid to 100 milliliter of water. That means 8% to 12% of solid. If it is there in a solution, that particular organic solution will lead to maximum gas production. That means you can imagine that how the liquid is playing a significant role, and that may be the reason why I have told you so many in details about the different groups of bacteria. They are participating in this particular activity to produce methane, which is a fuel gas for us. And that is the reason why I'm just telling that these type of situations are very, very important to note that which range under in which climatic condition, under which temperature situation we are trying to set up our biogas plant. Accordingly, the retention time or hydraulic retention time is to be decided. So if we are, that time I was talking about the fixed dome biogas type. So here this is the, it may be underground, it may be onto the ground also. Many a time we are putting the digester under the ground. Why? Because the surrounding soil which are there in the gasification process, it is acting as an insulator, so that any change in the atmospheric temperature will not affect much on the gasification process. So here, when we are going for this particular chamber, so we are taking the slurry, and this slurry is, as it is under the soil, we are not taking care of any insulation because it is a natural insulation process. And what we are further, we have seen, if it is onto the ground, if it is above ground, then many a time we are using insulators, and we are just surrounding that insulation thing on the wall of that gas. And if you are in extreme climatic conditions, say for example Kulu, Manali, now it is the temperature is much below 0 degrees centigrade. So in that case, there the extra heating arrangement should be there. So these are some of the precautionary measures which one should have for this gasification process. Now, many times the beneficiaries, they don't know the science behind it, and what they are thinking, they are doing, the gas which is there, they use that gas and they boil the water, and that boiled water and then the hot water is fed into the chamber, the digester. As a result, what is happening, that high temperature of that particular water, when it is added to the digester, the microorganisms who are working for us and those who are coming in contact with that hot temperature, they all die. As a result, the performance of the reactor is further getting low, and one day it is totally getting stopped. And that precautionary measure has to be taken. And while putting the temperature, one has to see that under any circumstances, the temperature within the water. So how to know? You may tell that, ma'am, beneficiaries are staying in the village, so how they will be measuring? They don't have thermometer to measure. So what I will be suggesting, that you tell to those beneficiaries, you touch with your own hand, and if you feel that you can touch that particular water, that is sufficient for enhancing the efficiency of the particular organism if the organism due to temperature has stopped functioning. And that may be the reason I'm just telling that your hand and your skin will be acting as the sensor for measuring the temperature. And if you can touch, if you can feel that it is tolerable to you, the all anaerobic or aerobic or the microorganisms who will be working for you will not die, and they will be getting the favorable environment towards the surrounding, and immediately they will start their activity. The advantages of fixed dome type biogas plant is that it requires only locally and easily available materials for construction. It is inexpensive, it is easy to construct, low initial cost, long useful lifespan, no moving or rusting part is there, which is there in KVIC model. That is the dome where this gas is getting collected. It is buried inside the fixed dome, and when gas is there, it starts moving up and up. But those part which is continuously in contact with the slurry is getting rusted. As a result, what is happening, after some time, you have to either repair or gas will be getting leaked through that holes, which will be there due to the rusting of this particular thing. So it should be well insulated. I have already mentioned you about the insulation. Basic design is compact and it saves the space, and construction creates the local employment. And that is one of the very important issue that should be also addressed. And here, during this particular cases through NABARD, that Atmanirbhar Bharat, when someone is interested to go for Atmanirbhar Bharat, one should also think of these points, and that should be considered. 2 hours continuously talking is very tough. So, along with these advantages, there are certain disadvantages. So, what are the disadvantages that one can face with the fixed dome type biogas plant? So, I have told you all the plus point, but as an entrepreneur, plus point is important, but you should thrive upon the negative, the disadvantages or the negative points, and you can then work on that, and you can easily overcome those type of problems which one can have. Frequent problems with the gas tightness of the brickwork gas holder, that is a small crack on the upper brick wall is there, and sometime through that gas may get leaked. So the major point which is to be, this is the very, very important thing. The moment you find that gas, total gas or gas production is getting reduced, first thing what you have to do is that you have to check the leakage. How to go for the checking the leakage? You just prepare a soap solution and spread on the digester. If you find that some bubble, because of the soap solution will get bubbled if there is gas. So if you find some bubbling is coming out from that, then immediately identify and mark that particular space and immediately go for the rectification process. So that way the leakage can be identified. In case the fixed dome model plants are there, they recommend only where the construction can be supervised by experienced biogas technicians, or else it is my humble suggestion to you that only go for cow dung based or the waste, that animal waste based biogasification process, because these are the all insolubles. And as I have already mentioned you, that lignin is one of the components which remain as such undigested, and once it is getting digested, it starts floating. Once it starts floating, and I think many of you have seen that scum formation on cow dung. So if it is getting exposed, then the upper layer is getting solidified. So it is the it helps this material, when it is lighter, it starts floating, and on the top layer it forms a scum layer, and that scum layer is creating a huge problem. And what is happening, initially there will be no problem, but after some time, with time, the thickness of scum is getting increased, and the lower, and when scum formation is there, the inner environment is very good. It is extremely anaerobic. So as a result, what is happening, huge gas production is taking place, and it will start producing pressure to the top layer, and one day will be coming, there will be a boom. So everything will be getting cracked, and the top layer will be getting burst, and it may sometime results on the cracking of the upper dome that may create a huge loss. If this is the crack which is due to the bursting of the scum layer inside the digester, then nothing can be done. No repairing thing can save your gas, and you have to once again reopen and reconstruct and go for the new gas holder. So this is a huge problem as far as this fixed dome is concerned. So if we are interested not to reach to such attainment, then what we'll have to do? We have to see, and we have to instruct the beneficiary that after a certain time, I have showed you that there are some inlet and some outlet. So put some bamboo and you break as much as possible from either this side or from this side. Whichever side is there, you just go for this particular disturbance of the scum layer, so that scum layer should not be continuous, and there should be some space for gas to accumulate within this gas collector. So these are some of the very important issues that are to be taken care of when we are going for this type of process. So when we are going for the gas plant, so what is happening? So this is the digester, and this is the sludge which is coming out. This sludge which is there, this sludge can be used as directly as a fertilizer. So what we can take? We can take some polyethylene plastics, that bags that can be there. Either we can use this bag this bag can also be used for collecting the gas, and we can make the connection to the kitchen for burning, or we can take this sludge and we can directly throw it to the garden and for doing the farming activities. So what is to be done is that if we are going for the biogas or biodigester, biodigester of this thing, then what is to be done? It consists of a long cylindrical bag which is made up of PVC or red mud plastics. These bag digesters are developed to solve the problem of handling, and it is not that costly because plastics are very easily available, and this plastic can easily be transported from one place to another. So here the same thing can be done, and the same thing can be taken, and it can be placed very close to the kitchen for ready use. And as soon as the gas is getting collected, the solid residue throwing here and there, you can take it directly feed it to the field for fertilizer activity. There are rubber balloons which can be used for the biogasification process. So when we are just going for this balloon for this gasification process, the purpose is same. Rubber balloon biogas plant is most simple and cheapest, and it can be done by anyone who are interested to collect the gas. Any plastic material can be used. The gas is collected in the upper part, and from where it is to be withdrawn. And the inlet and outlet are attached directly to the plastic skin of the balloon, and there is is now expansion chamber, and from there that can be used directly for the particular use, either for cooking or for electricity or any other work. When we are going for this digestion process, this digester can be of different type. One is that anaerobic filter, that is for attached growth digester. That means here the growth of the biologicals with the waste material is continuously, it is getting fixed, or USB. So USB is the upflow anaerobic sludge blanket digester. So these are some of the digesters which are used for huge construction. So when someone is going for industrial waste or community biogas construction process, then I will be suggesting that you please select upflow anaerobic sludge blanket digester. So these are the reactor which contain no packaging material. Instead, the methane forming bacteria is concentrated in dense granules of sludge blanket which covers the lower part of the reactor. That means the ratio between aerobes and anaerobes is properly getting maintained in this particular process, and that may be the reason. The moment 1 mole of acetic acid is getting produced, it is immediately getting converted to CH4 and CO2, the neutral product, and pH balance of the reactor is there. So the feed liquid enter from the bottom of the reactor, and biogas which is there, it is getting flowed or getting collected from the top part of this. So these are some of the construction of this biogas. If anyone is interested to go for biogasification process, first you have to identify that how big will be your size. Then second one is that what type of reactor you are choosing. Is it fixed dome or floating dome? If fixed dome, then what is the reactor type? So accordingly it is decided. Third, then you go for the measurement of this particular area, that how much will be your area and how one can go ahead with the system, that what area and how much will be the opening and how much is to be digged and how much will be the total capacity of that particular. Then you go for the construction of the particular digester. Then after this construction, then you have to decide that which one will be, which side will be the inlet and which side will be the outlet. And that way you just go for the construction and complete the construction. That brick and cementing construction is getting completed. Then only you have to have some idea about the inlet and outlet. So once inlet and outlet is getting over, then come to the dome portion, the upper portion where the gas will be getting collected. So this construction is getting over. Now you come to the dome construction part, and here that how you can go ahead with the fixed dome model, and then once it is there, then you just show that how the inlet and outlet is getting and total construction is completed. So this way the total construction of biogasification process is getting over. So many a time the hybrid people are going for the hybrid model. So up to this brick and cement, and total upper dome is a floating one. So that type of things are also there, depending upon your budget, what type of reactor system you are interested, that can also be there with this particular system. So once this biogas is obtained, we can use this biogas directly as a compressed gas, and in other word it is known as CNG, and it is used to power motor vehicle. In UK, for example, biogas is estimated to have potential to replace the 17% of the vehicle fuel. It qualifies for renewable energy subsiding the most part of the world. Not only UK, in Germany also, big biogas plants are there. Biogas can be cleaned and upgraded to natural gas standard, where it becomes biomethane. What is biogas plant? Now, if this is the question, a biogas plant is an anaerobic digester that produces biogas from any crop or anything. So it has a that gas holder, and that gas can be getting collected with the purpose for which it is produced. So what are the limitations? So the advantages of biogas is that it is green and everywhere, provided the carbon dioxide which is getting produced is taken care of. And another thing is that the residue which are there, it can be further divided into two parts, because gas is the gaseous phase, and now this slurry is there. This slurry can be once again separated into two parts. One is the solid part, another is the liquid part. This liquid part can be used as a foliar spray, and the solid part can further get enriched with N, P and K. And once it is further getting enriched, it can be distributed to the granaries or plant. And that way, if one can go for the economics of the biogasification process, then one can have this particular thing, that initial cost for installation of this biogas is little high if the digester is done in a proper way and with good insulation and all. So initial investment is there. But here the gas which is getting produced, if the total volume of gas or the percentage methane is getting improved, then the cost, it is substituting the electricity cost or the fuel cost, it is within a very short span of time, the entire money can be coming back to the system. So number of cattle is also another important issue which are there, that if anyone is not having the proper number of cattle, then should they not go for biogasification process? Of course, they should go for biogasification process, but there not that only lignocellulosics, but any organic food waste can be used for biogasification process. So biogas is such a product which can be bringing the economics, and within a very small span of time, the entire economy is coming back to the system. And that may be the reason why people are going for this alternative, any organic material they are thinking. So when you being the entrepreneur, if you are interested to go for the biogasification process and setting up a biogas plant, then what should you do, what should not? So if in a nutshell I want to tell, then I will be telling that you go and search for biogas that is based on cattle dung. So availability of cattle is very important. If you are interested to go for 1 cubic meter of biogas plant, then you can go for searching that cattle, number of cattle in that particular family. If that particular family is having 2 adult cattle, 1 calf, 1 cubic meter biogas plant can be constructed, because thumb rule is telling, although 1 cattle is producing 15 kgs of waste manure, but thumb rule we are telling that 10 kg per cattle, 10 kg, and if 25 kgs of cow dung is there and 25 liter of water is getting mixed, so total volume is 50 kgs and it is fed to the digester, one can get 1 cubic meter of biogas. And this 1 cubic meter of biogas can cook for 2 adult, 2 children. So 3 adult full meal for 1 day can be cooked. If you have 6 people or 5 people in your family or 4 people in your family, you should have
उसके बाद फिर नेट का प्रॉब्लम हो गया.
plant. You will be finding that excess gas is there, and that gas can be utilized for electricity or running the HP motor pump for irrigation purpose. So this is that means for 2 cubic meter plant 50 kg, 3 cubic meter plant 75 kg, 4 cubic meter gas plant is your 100 kgs. So for 1 adult cow, so it is 10 kgs. That means if a person is 10 cattle in his family, can easily go for 4 cubic meter gas plant. And if 4 cubic meter gas plant is there, then I think 14 to 16 people's cooking can be done per day in the family. And that way, I'm just telling that should be your first point. Second point is that, see, it is our nature's blessing. If we see the carbon and nitrogen balancing, this is a microbial process, carbon and nitrogen is playing a significant role. If the carbon and nitrogen percentage varies from 20 part of carbon to 1 part of nitrogen to 40 part of carbon to 1 part of nitrogen, that type of waste material is recommended for gasification process. If we take this waste and if we subject it for biogas production, we will be getting maximum gas. But the moment we are mixing some agro residues or food waste or something, this got disbalance. In cow dung, we are getting 30:1 carbon is to nitrogen ratio that is optimum for gasification process. And that is the blessings of our nature. And that may be the reason why I'm just telling that if you find that anyone is having sufficient cattle, don't go for any other additives in the digester. Or else, many a time, we find that carbon is more and nitrogen is less. So in case you find that your digester is not giving gas, and you are adding lignocellulosics and cow dung together in the digester, just in a village, you will be getting some urea. You just take some urea, put it in water and just punch it in the digester. Keep it for 2 to 3 days. If nitrogen carbon balancing is the only reason for stopping the fermentation, you will immediately get your gas within a small span of time. So these are some of the issues I have already mentioned and I have already talked. And if you have any query, any questions, anything, you can tell me and I can answer you, and I will love to address that thing. So with this, I'm just thanking you all for your patiently hearing. Thank you.
Thank you, ma'am, for an excellent session on biogas and biofuels for rural electrification. Now I request the participants to interact with ma'am.
Good evening, ma'am. This is Ram. Thank you so much for the detailed session. My question is, right, using kitchen waste, how effective it will be how cost effective it would be to build such a unit?
Yes, you are interested to know about the kitchen waste.
Yes, madam. So if you want to build a small unit using the kitchen waste, how feasible it is or how cost effectiveness it would be?
Stop sharing. Yes, you are interested to go for the kitchen waste. So, and how economic that a kitchen waste based biogas plant. So you have to have some idea about how much kitchen waste you are getting. If it is, I'm just giving you one example. At IIT Kharagpur, we have student hostels, and in student hostels, we are producing huge quantity of food waste. And what we have suggested is that we will be collecting that waste, and we will be taking that waste for biomethanation process. And what I have suggested with my groups is that we are taking the waste, food waste from the hostels, and we are going for the classification of waste. You will be wondering to know that although this particular composition of waste is starchy enriched food ingredient, here and little bit of a very low percentage of oily stuff. We have gone up to 72 to 74% of methane in gas composition. This is the research which we have carried out in IIT Kharagpur. From that, now you have to tell that how much is the waste you can collect. bioconversion process. So here, if your initial raw material is different, if it is lignocellulosics, I have told you that go for the hydrolysis, gluconeogenesis, this acidogenesis, and followed by methanogenesis. But if it is starchy based process, then in that starch-based process, you have to have some idea that here this it is getting, the starch is getting converted to glucose. This glucose is immediately entering to the acidogenesis and immediately it is getting converted. So entire period of the conversion is also playing a significant role. In our laboratory condition, within 5 days, I was talking about 25 to 100 days, depending upon the temperature condition. But in laboratory condition, under ideal, that 30 to 35 degrees centigrade, if the ingredients are the starchy waste or food waste, we have started getting biomethane within 5 to 7 days of time. Not even 5 days, so before 3-4 days, 3 days methane started production. And it came to the standard level when we entered to the 7 days onward. So this is the very, very important parameters which one has to see, that what are those, what are the major composition, how much is the nitrogen part in it, how much is the carbon, and if it is an ideal condition, then you can get very high methane percentage.
Okay, yeah, thank you, madam. Getting some idea. And the individual house, we may be getting some 2 to 3 kgs of waste per day, but collectively in the apartment, maybe a bigger quantity. And like you said, it's on the composition, we can think about a solution.
Ma'am, I have one question. Like in a thermophilic process, you are telling that the gas is generated within 6 to 12 days. If the thermophilic process is there in a gas chamber, then we can use that solar energy with that some cutoff temperature, like you are 45 degrees Celsius or 60 degrees Celsius. It can work.
Yes. Why not? Yes. Very good idea.
Yeah, the idea is good, but any experiment is done on that? The gas formation is come within that 6 to 12 days. If we temperature maintain above 45 and below 60 degrees Celsius, anything? This is my query, ma'am. General query.
Yes. No. Temperature is one of the very, very important parameter that is playing a significant role on the total gas production and overall productivity of that particular process. So here, when we have gone for this methane generation, although we have not used solar, but we try to keep the temperature within the range. And what we have seen is that the total production of methane is not at all getting varied. It is continuously maintaining some strain and it is attaining the maximum within that range. No fluctuations are there. Temperature, if it is not there, then only efficiency of the microbes is getting down, and then only there is some variation in the production or productivity.
Ma'am, second question, like in the paddy straw or rice straw, how much days it take to produce the gas? Because the decomposition process is higher in that case, no? If we go with the thermophilic process, what you suggest?
Thermophilic is not the solution, answer of your question. See, I'm not telling that thermophiles, when the temperature is going much beyond 40-45 degrees centigrade. Generally, in summer also, we are not crossing 45 degrees. So that is the reason why I'm just telling that it is a mesophilic condition. So under mesophilic condition, it is giving optimum result. Thermophilic means if extreme place in Rajasthan where temperature is going 50, 51, 52 degrees centigrade, this is rare. for 1 or 2 days. But mostly the bacteria which are participating in the bioconversion process, their metabolic activity is maximum or optimum in the mesophilic zone. And that is the reason I'm just telling that temperature is playing a significant role.
Okay, thank you, ma'am. But you tell everything about that biogas. I am very thankful to you because I learned a lot. Thank you. Thank you.
Thank you. Thank you very much. So if you can bring this idea to the practicality, then only this 2 hours teaching will be fruitful. So I want to see that some of you are coming with this new innovation that are most challenging, that no release of carbon dioxide to the atmosphere and proper utilization of carbon dioxide. So these 2 issues are most important in biogasification process.
Hello, ma'am. Hello.
Yes.
Ma'am, do you have any idea about LPG cylinder refilling with biogas? Large biogas plant?
This is a very, very good question. So I'm just telling that LPG is, I think you know, LPG composition of LPG. So if we see this gas is being liquefied, but I have told you regarding CNG, but I have not told you about liquefaction of biogas. If we go for liquefying biogas, it has been seen that it is not economically viable. It needs very high pressure and very low temperature, and that is not feasible. And that vessel's thickness and the temperature is not very, very economic. And that may be the reason I will not go for that LPG equivalent, but I will suggest you, why don't you think for CNG substitute, and you can do it very easily.
Okay. Thank you, ma'am.
Okay.
Looking forward to meet you.
Thank you.
Hello, ma'am.
Ma'am,
Yes.
ma'am, I am a doubt, ma'am. We own 4 cows, and is it possible to keep a biogas plant which is commercially available, or we need to build it up, ma'am?
You have four cows.
Yes, ma'am.
Yes. That 4 adult cows.
Yes, ma'am.
Yes. Of course. You should go for gasification, and you will be getting very good result.
Do we need to consider
issues for which the gas product is getting? Okay, I think I have addressed those issues because last 30 years I'm working in this particular area, and that is why if you ask me any question related to this field, I feel that I must answer. That is the reason why I'm just telling that yes, you should go for if you have 4 cattle, you should immediately think for this biogasification process.
Ma'am, as you said, we can
Hello,
produce current from this biogas. How the current electricity is produced from the biogas, ma'am?
You put one micro turbine, and that micro turbine will convert this gas to electricity. You need not have to do anything.
Hello, ma'am. Can we run automobile through biogas?
Yeah.
Automobile engine through biogas. Can we run automobile engine like cars and?
Yes. That is the reason why I'm just talking about the CNG.
So what is the disadvantage? What is the disadvantage?
I think in Delhi you must have seen CNG.
Yes.
Yes, this is same. This is same as CNG.
But ma'am, every limitation has some postulate like what is the disadvantage?
No disadvantage is there. It is up to you, your choice. It doesn't have any major disadvantage. Your choice, you can use it.
Hello, ma'am. Hello.
Yes.
Hello, ma'am. Hello.
Yes.
Hello, ma'am. Actually, I am belong from Tripura, and actually, I have a integrated farming. I am doing like that. A small unit of cattle farm and also pig farm, also ducks and goatry. Everything I am rearing. So I have a 5 numbers of cattle and also 16 number of piglets are there. So many wastes are every day wasting. So I have to use this kind of thing for biogas plant as well as for electrification.
Yes. Of course, yes.
So, ma'am, I need to your help. Actually, I need your email address, and also I want to contact further after the completion of that program.
Yes.
Actually, also I have made, ma'am, one egg hatching machine. So recently, my production is near about more than 200. But problem is that there is a electrification. Actually, I am from village area. So maximum times load sheddings are occurring. So recently I have buy a that battery means inverter, but that also sometimes problem occurring. So I want to use for electrification with the help of biogas. So that's why actually I have to attend this program, ma'am.
No problem. You are from which place?
Ma'am, actually I am belongs from Tripura.
Oh, you are
Northeast.
from Tripura. Okay.
Yes, ma'am.
No problem. Tripura is very close to Kolkata.
Yeah. Yes, ma'am. So actually, I want to contact with you, ma'am. So actually, recently I am trying to work on this, ma'am.
I will be more than happy. What type of combination you want? You just tell me, and I'll be giving you the solution. Okay. By sitting
ma'am.
here,
Actually,
I will be telling you, and I need not have to go even to your place. You will be telling me the condition of your plant, and I will be giving you the solution from sitting here on.
Okay, ma'am. Thank you, ma'am. I can contact you, ma'am.
My address you will be getting. You just open our IIT website. Come to Agricultural and Food Engineering Department and just see the head of the department, and you just click to that. You will be getting that email of HOD, and you write to me in that ID, and I will give you the reply.
Okay. Thank you, ma'am. Actually,
I will be able to give you the solution. It will not be a problem, my dear. Okay?
Okay, ma'am. Actually, my friends also are doing PhD in your IIT, ma'am. So, my friend is also doing PhD in IIT Kharagpur in Mechanical Engineering Department.
Okay.
Actually, I am from mechanical background, so he is doing PhD. So, one teacher, actually, I have completed my BTech from NIT Agartala, ma'am.
Okay.
So recently I am working in farming. So means the integrated farming I am doing. So like that cattle farm, goatry, piggery, everything I am doing. So recently,
people like you should come to agriculture, because agriculture is no more that it is illiterate things. Nowadays it is precision agriculture. And
yes,
I will be going for integrated. I will give you the concept for integrated farming.
Okay, ma'am. Thank you. So, ma'am, actually, recently my aim is to make a biogas plant and with electrification with that.
Yes, it is highly possible. It is very much possible.
So, ma'am, I need your help, ma'am.
No problem. You can ask your friend to meet me here, and he can talk to me. And in my laboratory, it is a continuous. My students are also working. He can come and he can see also that how and in which way we are increasing the percentage of methane.
Okay. Thank you, ma'am.
Okay. So you do. Yes, very good proposal, and you should do that. Yes.
ম্যাম 1 কিউব বায়োপ্লান্টের জন্য কত পরিমাণ কাউ ডং লাগে আর কি?
আমি এক্ষুনি বললাম আমার লেকচারে 1 কিউবিক মিটার যদি নাকি বায়োগ্যাস প্ল্যান্ট হয়, then you need 25 kgs of cow dung, wet cow dung as such. And in that wet cow dung, 80 to 85% moisture is there.
আচ্ছা,
ঠিক আছে, সেই জন্য যখন নাকি আমরা রেকমেন্ড করি, আমরা বলি যে 1 বালতি যদি গোবর হয়, 1 বালতি গোবরে 1 বালতি জল দিয়ে ভালো করে যদি মিশিয়ে গ্যাস প্ল্যান্টে যদি ঢালা হয়, then the total solid of that particular solution is coming 8 to 12 part, 8 part to 12 part of solid in 100 milliliter of water.
আচ্ছা ম্যাডাম, ওটা শুধু কিচেন ওয়েস্ট এবং
কিচেন ওয়েস্ট এর মধ্যে দাও, তাহলে আমি তোমাকে বলে দিচ্ছি যে তোমার এন্টায়ার কম্পোজিশন is getting changed.
Hello, ma'am. Hello, ma'am.
থ্যাংক ইউ ম্যাম।
Okay.
Hello,
So
hello.
in that case, you have to go with trial and error.
Hello, ma'am. Hello,
Yes.
ma'am. Now I am pursuing agriculture engineering from Nagaland University. So, ma'am, can you please tell me how can we purify biogas?
Very simple. Means what type of purification you need? You want to remove carbon dioxide from biogas.
Yes, yes.
So you go for water scrubbing. Very simple. You can go for alkali scrubbing. So the scrubbing is a very, very common thing. And there are many other techniques, but I'm not telling, but I'm just telling that commonly what people can do. Okay. Any more questions?
Hello.
Yes.
Namaste, ma'am. Actually, I want to know that how can we use the cow dung on a big scale? Like we are seeing that a lot of gosala is everywhere in India,
Yes.
and all gosalas running only on donations. I want to know that which mode we have to use or adopt so we can sustain the gosala. Without donation, how can we run the gosala to use of the cow dung?
I don't know that donation or what thing is not known to me. But why they will be running with donation is not clear to me.
Because ma'am, they are having the lack of knowledge. They don't know how to use the cow dung.
Maybe. You see, I forgot. Just that is the reason why I was thinking that you will be asking me question and I will be answering. But instead of 2 hours, I went on talking. My phone got.
No. Actually, ma'am, the thing.
No, I'm just telling you one thing. The cow urine which is there is very rich in nitrogen. In case you are adding some agro residues, I think some earlier person, that student who was asking me about this gasification process, so he was talking about this composition of kitchen waste and cow dung together.
Yes, ma'am.
What I'm telling that sometimes if you find that gas percentage is less, you instead of adding water, you pour some urine, cow urine.
Okay.
Solve your problem.
Okay, then, ma'am. According to you, if we go on the CNG, because in Gosala 100 and 200 or 500 adult cows are there. Okay.
Then you see that how much I can do and how much gas I can produce. 200 to 500. Do you have any such connection? And immediately then I will be telling you that you take that entrepreneurship immediately. And I can promise this much that I will help you.
Yes, ma'am. There are a lot of gosala, ma'am. Actually, I'm working on that.
Okay.
In Rajasthan, also a lot of gosala is there like this.
You please utilize. This is our natural resource. It is the blessings of our nature, and we must utilize those for some fruitful product.
Okay, ma'am.
One question, 1 metric cube, if that gas chamber, if that gas is not coming, we can add how much percentage of urea? Hello?
Can you
If,
repeat?
yeah, if digestion in the gas chamber is not take place, how much percentage of urea we can add so that process go fast, ma'am? Because you are telling that.
You have not understood. You have not understood me. If I told you, in case you are producing gas and you are getting gas every day, it is okay. In case you find that total gas amount is reduced or it is in the declining, that a little bit of less percentage of gas is there, in that condition only you just put urine, not normal.
I am talking about urea, ma'am. Urea. You tell me na urea earlier in your presentation. You tell that you can use urea also.
Urea is a nitrogen substitute.
Yeah.
It is.
Okay.
I told carbon is to nitrogen, and because here this nitrogen urea can substitute, and urea is very cheap also, and people that farmers, they are just spreading it in the field cultivation during cultivation.
Can you please tell us about the cost? I mean, say 10 cubic meter unit will cost how much?
Cost
of construction of 10 cubic meter with the production of 10 cubic meter of biogas?
No, I cannot. Because where you are going to set up is very important. How far it will be from the resource, how much will be the transportation cost. As such, I cannot. No.
Okay.
I cannot. But
yes, ma'am. Good evening.
Biogas construction, as such, in general comment I'm just giving. Biogas is otherwise known as, this is the blessings of Almighty to the poor. So biogas construction, biogas plant construction is not very costly. So whether it is 1 cubic meter or 10 cubic meter immaterial, the size will be getting increased, and if you have availability of place, you need not have to procure the land, then cost of construction will not be at all high.
Thank you.
Thank you.
Yes, ma'am. Good evening.
Good evening.
Yes, ma'am. Plant.
Hello.
How much cost it will come?
Hello.
Mini plant. Hello. Yes, ma'am. How much cost for a mini plant if invest?
Yes, ma'am. How much cost for a mini plant? What
Yes,
do you
ma'am.
mean by mini plant? What is mini plant?
1 cubic. Yeah.
Very low. You just tell me what is the what type of plant you will be constructing? Fixed to floating
Yeah.
to?
Biogas. One cubic biogas plant. How much cost it will?
I'm just telling that what type of design you will be opting for.
It's a mini plant, ma'am. Only home excretes and home rotten vegetables and
No. You have not understood. I'm just telling you that what type of gas plant design you are opting for. Is it KVSA? Is it Dinobandhu? Is it Pragati? There are different types of models.
Yes, ma'am. Yes.
So each
Yes,
time, if I'm taking that Dinabandhu model, so Dinabandhu model is not at all costly. Very cheap.
How much, ma'am? Minimum 50,000, below 50,000.
Yes, yes. Much
Okay.
below.
Okay. Thank you, thank you, thank you.
Not
Thank you.
even 50,000.
हेलो मैम, हेलो।
Yes.
हम लोग के घर में मैम बहुत पहले गोबर गैस को ही बायोगैस बोलते हैं ना।
Yes, yes.
तो हम लोग के यहाँ बहुत पहले था, लेकिन बहुत दिन से बंद पड़ा है। तो अभी अगर हम चाहेंगे उसको फिर से स्टार्ट करना, तो क्या हमको दूसरा सेटअप तैयार करना होगा या सेम सेटअप में हो जाएगा?
नहीं, आपको फिर हमको यू हैव टू टेल मी दैट क्यों वो गैस का प्लांट बंद हो गया था।
यूज कोई नहीं कर रहा था जनरली, इसलिए बंद कर दिया गया था।
ना ना, आपको फिर किसी को देके दिखाना है कि वो गैस प्लांट का जो कंस्ट्रक्शन हुआ था, वो कंस्ट्रक्शन क्या ठीक ठाक है या प्लांट कंस्ट्रक्शन में कुछ डिफेक्ट आ गया। If there is some defect or there are some problem in the digester and the collector, then you have to go for the new construction.
Okay, ma'am.
In case if you find that yes, gas chamber and construction में no problems are there, then in that case you can restart the process. No other cost will be there. आप फिर उसको दोबारा स्टार्ट कर सकते हो अगर आपका प्लांट जो है वो कुछ क्रैक नहीं हुआ या ब्रेक नहीं हुआ या ये ठीक ठाक है।
Okay, ma'am. Okay, ma'am.
I don't know how much good Hindi I have told, but I tried.
It's good, ma'am.
आपको समझ में आया ना?
हाँ, आ गया।
Yes, yes. Yes, yes. So thank you, Machavaram.
Thank you, ma'am. Even in your very busy schedule, you have accepted.
People there waiting, so I'll have to know. Yes.
Yeah, and all the participants, if you have any query, you can just mention in the feedback form. Thereby, you can communicate to ma'am. Thank you, ma'am, for accepting our invitation for the lecture. Thank you once again, ma'am.
Thank you very much.
Thank you, sir.
But these people should come up with the gas plant construction.
Yes, ma'am. The information the participant will use it properly.
And they should take it.
And yeah, come up with
I have
it.
stayed 2 hours. So see, it's such a big queue. I don't know when I'll be going back home. But they should do this. Then only I'll feel that yes, this much of teaching is worth. Okay.
Thank you, ma'am. You have extended, I think, extra 40 minutes for the session. Yeah.
No, but the thing is that I got delayed in starting. So that is.
Okay. Thank you, ma'am. Thank you once again.
Thank you.
So can we get email ID of ma'am? Possible, sir?
Yes, it is possible. You can share head as the. Okay.
Thank you.
Okay, all the best to all participants. Okay. Hope you will have a very nice time ahead and you have already enjoyed. Thank you. Thank you for your.
Yeah. Thank you so much, madam.
Thank you. Thank you all.
Thank you, sir.
Thank you. It was so informative.
Thank you, sir.
Ralia.